Okay, if you're unfamiliar with the Agilent X Series Spectrum Analyzer, we're going to introduce you to some of the features of the Spectrum Analyzer, and particularly those that are of interest to the EMI user. Let's start by looking at CISPR presets under the Mode Setup key. For EMI users, you will find a useful family of CISPR presets, which lets you easily set the analyzer to particular CISPR bands, including setting the number of points in the sweep to have 2 trace points per res bandwidth. So in this case, with a res bandwidth of 120 kilohertz, we've set the point spacing in the sweep to 60 kilohertz, giving you 4,503 points. With the X series, you can set up to 40,000 sweep points, allowing you to resolve very narrow signal spacings, even in a wideband sweep. And notice that the sweep time is impacted very little by changing the number of points. Now let's talk about some of the other labor-saving features of the X series. First of all, you have up to 6 traces, which you can operate in any of 4 writing modes, including trace, average, and max hold. You can display all the traces at the same time if you like, so I can turn on an average trace at the same time as a peak trace, and all the traces display in different colors so it's easy to distinguish them. Also, we have up to 12 markers, which you can use to gain more insight into the behaviors of specific signals. You've got peak search functionality that lets you easily look at different peaks in your system. You can turn on a delta marker, which allows you to look at the differences between peaks. You can turn on marker functions, which let you measure power characteristics of specific signals. And with the marker table, you can look at all of your markers at the same time, including the marker functions as well as the delta markers. And again, all 12 markers can be displayed simultaneously. I can also turn on a peak table, which will show me the top 20 peaks in my signal. And this is not related to the marker functionality. I can turn all the markers off and still have my 20 peaks displayed. And these peak table peaks are real-time functions. If I change some functionality, like if I change the peak threshold so that the number of peaks that are being displayed changes, this all happens real time. So peak table, marker table, traces and markers, marker functions, some labor-saving features of the X series analyzers. Let's go back to our CISPR preset and take a look at some other features of the analyzer. Besides the swept mode of the analyzer, all X series analyzers also have FFT sweep modes, which the analyzer will automatically choose if you get into a narrow bandwidth. For example, if we were sweeping over a narrower span, say 1 megahertz, and we lowered the resolution bandwidth to, say, 200 hertz, you can see that it automatically switches into the FFT sweep mode, which speeds up the sweep time to 232 milliseconds, as opposed to the value 40 seconds, which is what it would have been if we'd stayed in swept mode. All Agilent X series analyzers contain a digital IF, which is particularly nice when you're making EMI measurements. I'm going to explain that. First, I'm going to preset the analyzer, and now I'm going to switch from an antenna to a signal generator. So hang on just a second. Okay, now I'm back driving a signal about minus 10 dBm at a gigahertz into the analyzer. And one of the labor-saving features of the X series is this auto-tune functionality that automatically tunes to the strongest signal in the measurement range of the analyzer, sets the span to show the whole signal bandwidth and sets the reference level so that the signal is 10 dB below the top of the screen. So now I can show you that it doesn't matter where on the display that I placed the signal, the value that you're reading doesn't change even when you put it off the top of the screen. There's no dependence on the display placement of the signal for accuracy, which is not true when you're dealing with an analog log amp. Another advantage of the digital IF is that you can use a single signal path to make all your measurements, even with the EMI detectors, whereas with analyzers that have an analog log amp, you have to use a different signal path to make normal detector measurements as opposed to EMI detector measurements. So the accuracy of the X series for EMI measurements is unsurpassed. Of course, the X series includes an overload detector. Anytime the signal amplitude gets too high, the overload detector will go on, instantly telling you that you need to reduce your signal level. And this is absolutely crucial when you're making EMI measurements. If you get an overload, it's going to invalidate all your readings, even at other frequencies. So the overload detector is an essential part of the digital IF. Okay, let's go back to the antenna, and let's go back to our band C CISPR preset, and I'm going to show you the limit line and amp core capabilities of the X series. So you can load amplitude corrections. The analyzer supports up to 6 corrections simultaneously, and it's easy to load them from mass storage. You just go into the mass storage system, choose amplitude correction, and then it's easy enough to find the EMC limits and amp core files that are preloaded on all of our analyzers. Let's load an amplitude correction that includes an antenna factor. How about this biconical antenna here? And you can see that when you turn that correction on, you do get a change in the amplitude characteristics of the signal you're measuring. You can even edit the correction factor using Agilent's advanced correction editor. You can see that as you move through the correction table, the little cursor follows you across the screen, and you can get to any particular point and easily edit the amplitude of that point. I'm turning the knob to show you how easy it is to edit data in the corrections table. Besides corrections, the analyzer also includes a set of limit lines, which are useful when you're making EMI measurements. If I go to the limit file type, again, the analyzer includes a set of preloaded limits, or you can define your own. In this case, I'm going to choose an EN55022 limit for, let's do 10 meter radiated. So there's your limit line, and you can see that the signal, if it crosses the limit line, turns red, which makes it very easy for you to see when you've crossed your limit. When you turn on a margin, you can see that if it crosses the margin, it turns amber, and it'll tell you in the corner whether you're failing your limit, failing your margin, or passing. Just as with amp core, you can have up to 6 limits. Each limit can apply to one of the 6 traces, or you can have multiple limits apply to the same trace. You can have up to 2,000 points in a limit array, just like you can have up to 2,000 points in an amp core array. That's a lot more points than were supported on our earlier analyzers. And there's a limit editor, just like there's an amp core editor, which lets you go into the limit array and adjust the frequency or amplitude of any of the points in the array. So you can see that it's very easy. I'm turning the knob here to adjust the amplitude of this particular point in the limit array. It's very easy to adjust the values in a limit line using the limit editor. You can insert points, you can delete points, you can customize limits pretty much any way you like. And of course you can save them off to mass storage as CSV files, which makes it easy for you to edit them in Excel. You can do that with amplitude corrections as well. Now there's another interesting capability in the limit editor called build from trace. I'm going to go build a different limit from trace 1. I'm going to build limit 3 from trace 1. Notice limit 3 applies by default to trace 2, so when I went into the limit editor, it turned on trace 2, which I'd previously saved as the noise floor of my measurement. So if I build limit 2 from limit 3 from trace 1, now you can see the blue line there is a limit that was built from trace 1. That makes it easy for you to build a limit line based on the behavior of some kind of a golden device that you want to use to test other devices with. And you can see that it's reporting the limit results for both trace 1 and trace 2. It'll report limits for each of the 6 traces here in the corner of the display. And then the summary area here shows you if any of the existing limits is causing a failure to any of the traces. So a lot of capability built into the limit system and the limit editor. I'm going to turn off trace 2, and I'm going to delete limit 3 because the display is getting a little busy here. Okay, so we talked about mass storage and how you can save limits in the AMP core as CSV files. Well, no mass storage system would be complete without the ability to easily do screen dumps. When you ask for a screen image on the X series, not only does it make it easy to generate the screen image, but it actually shows you a thumbnail representation of the image that it's going to dump, so that you can verify that this is what you are after. You can go into the Save As dialog and save your image to internal memory. You can save it to a thumb drive. You can save it to a network drive. It's easy as pie. And once you've saved a file type, whether it be a screen image or a state or a trace, the next time you push the quick save button, it saves another file just like the one you previously saved. So if you want to save screens, it's easy to do screen dumps all day by just continuing to hit the quick save button, and it simply increments the suffix in the file name, making it really easy for you to do screen dumps at any time. Also, as far as states are concerned, we have 6 built-in state registers. If you save to one of those, it shows you the time when you made the save, and that makes it easy for you to see what registers you've been using and identify what states are in what registers. And of course, it's easy to save states to files as well, again, on a thumb drive or a network drive, as well as to internal memory. There's also trace registers available when you want to save traces. With every trace save, you get the state of the analyzer. So when you load it back in, you'll get all the settings back that you had when you saved the trace. So there's a quick look at the X Series Spectrum Analyzer and some of the labor-saving features that it provides. Now let's go on and talk about the EMI Receiver app.